Tonight we're going to do another experiment. I have done experiments in the past comparing different exposure rates between the 10-second, 20-second, 30-second, and the 60-second exposure rates. Tonight I want to do a little bit more focused experiment, and I'm just going to do comparisons between the 10-second and 20-second. Both of those are fairly efficient for me, but I want to do an experiment to see if we can narrow down which one really is working the best for us. And so what I'm going to do is I am going to go into my Seestar and go to the advanced features, and I've set it to the 10-second exposure rate. I do have it set up on EQ mode, and you can tell that back here at the home screen. There's a little icon in the top right-hand corner right by the battery indicator that shows that the Seestar is in EQ mode. And so that's the indicator. I'm going to devote maybe a little bit more time than I have on past experiments, just because I'm going to narrow it down to 2 different exposure rates, not all 5 of them. And so I wanted, I'll start with the 10-second one. And I haven't quite decided how long I'm going to do, so maybe I'll figure that out as it's imaging. So what I'm going to do is I want to do an object that is fairly common. I have already done the polar aligning. I've already set up the Seestar. It's outside ready to go. Then I'm just going to click on the stargazing, and then I'm going to do one of these best right now. And those 4 right there that are showing, those are the ones that are best and highest on the list for best. So I think I'm going to do that M51. I've done this one several times, but that one appears fairly quickly. But as you add exposure time to it, it just gets better and better. And so it hopefully will be a good one to image. So then I'm going to click on the M51. It shows me its trajectory on the sky there at the bottom. And so we have pretty much all night that we can do this one. However, I am going to go to bed at some point. So I will probably set up a plan to do the 20-second exposure rate. Maybe I'll try doing about 2 hours on each exposure rate. So this one is going to be the 10-second one. I'm going to go ahead and start the 10-second one. I'll make a note that it's at 9:55 p.m. Well, I'll wait until it actually starts imaging before I do the timer, but we want to keep track of what time we started, and then we'll keep track of how many exposures it saves, so that we can compare the efficiency between the 10-second and the 20-second exposures. So that is my plan tonight, and I will bring you back as we have more things to report on. Right now it's already found M51 and it's just doing the autofocusing. I am not going to turn on the light pollution filter. It's a Galaxy. They don't recommend you do that, and it wouldn't be beneficial. The only time I turn it on Galaxies is where I know that it's kind of pointing at street lights, that yellow kind of light that can come in sometimes. But I am pointing to the north, and I have a pretty good view to the north. So I'm not going to turn on the light pollution filter for this experiment. So here we are. We've started at 9:56 p.m. and it's starting to image the first one. And again, just a reminder, this is the 10-second exposure rate. I'm thinking I will do 2 hours, and then I will switch it to the 20-second and do 2 hours. So it has saved its first 2 exposures, 3 exposures. They don't always do it they don't click off the exposures like a clock does. The timer down at the bottom does, but the one at the top, it can sometimes plate solve and stack the images, not necessarily on clock time. So we've already got 4 images, and we can already see that M51 materializing. And so that's part of why I chose this one, because it materializes pretty quickly. So we will do this for a couple hours, and I'll bring you back, and we will talk about more as we go. So I'm going to have to set up a plan because I'm going to go to bed. Uh, I'll stay up long enough to switch it from the 10-second exposure rate to the 20-second exposure rate. I'm going to do it for 2 hours. So just a few minutes before midnight, I will switch it to the 20-second mode, and then I will set up a plan. So what I'm going to do is I'm going to go out to the main screen, and you see that there's still an orange box around that stargazing. That means it's imaging. And so I'm going to set up a plan. I'm going to click on the plan. And at the very bottom, I'm going to create a plan. And I'm going to name this one 10-second, 20-second experiment. I'm just going to abbreviate it and confirm. And now it wants me to add an object. I'm going to go on the top right and click on object, and then click on M51. And that's what I want to add. So I'm going to locate that target, and then I'm going to add it to my plan. And so I'm going to start this one at midnight. That gives me about 4 minutes to go in and change it to the 20-second exposure rate before I need to start it. And then I'm going to have it image for 2 hours. So it will be exactly like we're doing for the 10-second exposure rate. I'm not going to do anything with the light pollution filter, not going to do any of the darkening, enhancing, anything in the app. I'm just going to let it run. But, when I'm doing a plan, I don't really want it to end at 2 p.m. or 2 a.m. Sorry. I want to fill up that plan a little bit. So I'm going to add something else. And there's something I've been wanting to image that I haven't been able to image for very long. And I want to do that Iris Nebula. And so I'm going to locate that one and add that one. And you see it's going to be up in the sky almost all night long. So I am going to add that, and I'm going to let it run the last part of that night because I don't want to waste the night. So the first object we're going to do is that M51 for our little 20-second exposure experiment comparing with the 10-second. And then the bigger part of the night, I'm going to image that Iris Nebula and see what we can come up with. I've been wanting to do that one. So this is what we're going to do through the night, and I will bring you back as we make some progress. So I brought you back a couple minutes before the 2-hour mark is up. We've got about 2 minutes left. I brought you back so that you could see that it has 1 hour and 25 minutes of saved exposure. So it's dropped about a half hour out of the 2 hours of the exposures on this 10-second run. I do have to be pretty efficient at switching it up to the 20-second thing because I only have about 4 minutes between 11:56 and midnight when I need to have that plan started. And when I go into the settings, it will have to do the calibration to the 20-second exposure. So, and that, I think it takes about 2 minutes to do that. So I can't really waste any time doing that, but we'll calculate out the numbers when we have the data from both exposure rates. But I wanted to show you it's looking pretty good. That is just straight off the Seestar. No denoising or anything is involved in that. I haven't darkened it. I haven't lightened it. I haven't cropped it. No light pollution filter. That's just straight off the Seestar. And it looks like it'll probably won't get to 1:26. An hour and 26 minutes before the time is up. But we'll calculate out those numbers as it comes up. So what I'm going to do is I'm going to wait for it to click to 11:56, and then we will stop this imaging and then go into the settings and change it to the 20 second exposures. That was kind of a tongue twister. All right, so we're at 11:56, so I'm going to stop that, and it will save it to the phone, and then I'm going to go back to the main screen, click on the advanced features at the bottom and change it to the 20 seconds, And then I will go back to the main screen, and then I'm going to start up that plan. And that's that plan that we created earlier on. And let's see if it is already doing that calibration thing right now. I mean, I don't see it happening, but it might do it when I start the plan. So we would probably want to know that in case we need to deduct those 2 minutes from the time that is taking. So it's going to take a couple minutes to get there. It's got about 4 minutes before it starts the plan. And this is what the main screen looks like. That green line going across the middle is telling us that there's a plan executing. It usually comes up and tells you that it's calibrating when you change between the exposures. And I didn't see it do that, but maybe because I didn't go straight to an object, there's a little bit of time in between here. And so I don't know if it's going to do it now or if it's going to do it when the plan starts, but I'll keep watching that because we want to make sure that we're being as fair in our minutes as we possibly can for this experiment. We've got probably about 2 minutes left. Let's see. I'll bring you back when it's closer. Before the plan is going to execute. So I'm just kind of curious if it's going to do that calibration that it does when you switch between the exposures. It might be doing it behind the scenes because we didn't go directly to an object, but we'll find out here soon as soon as it starts looking for that object at midnight. It's 11:59. It probably has 10 seconds before it starts finding it, and then we should know. I hate to just leave you hanging there, but I don't really want to shut it off because I'd have a hard time getting it to restart the video and record it without if I stop it. All right, there it is. It's going. Let's see what it's doing. It's locating the target. Well, I can't really remember. It's been a while since I did the exposures. There's the 2-minute break. So it's going to do that enhancing. It's what it's called, I guess, not calibration like I've been saying. It's the image enhancing, and it takes about 2 minutes. I don't think there would be a way to avoid doing that because in the plan you can only set it by 10-minute exposures. I guess the only way I could have done that is actually gone to the object and found it and then stopped it and then started the plan. I mean, that would have solved it, but I wasn't sure if that's how it would work. So we'll just have to know that there's 2 minutes less of time devoted to capturing exposures on this 20-second exposure part of the experiment. That's a good thing to know for future videos or future experiments. If I didn't known, I would have put a little bit more time and given me a little bit more time in between so that I could have found an object and so there wouldn't be this 2-minute delay. But, you know, it is what it is. As soon as it starts imaging, I'm going to go and hook up a battery to the Seestar so that it will maintain enough power for the night. And then I'm going to go to bed. So the rest of the plan for tonight is to leave it running. I'll check everything out in the morning and we will compare the data and the exposure captures, and then we'll compare the images themselves. So good night for tonight, and we'll see you in the morning. All right, it's the next morning, so we're going to see how it went. So we're going to open the Seestar app, and it will need to connect again because my phone in the night is not close enough to stay connected. So it just automatically does that, and it reconnects. What we need to do is let's check and see how the plan went. So we click on the plan, And there at the top, you can see those green boxes around the two objects that we imaged last night. That is telling me that those succeeded in their plan imaging. And so we should have two images in our on our Seestar that were saved from last night. And so let's go back into the My album, and it's asking if I want to keep the current selection, which I do. You see here on the saved plan, there's only one M52, that one in the top left. That is the one that we imaged yesterday that ended right before midnight. And when it ended, it asked me if I wanted to save it, and I did. And so it saved into this saved folder. The one in the plan, I wasn't awake to do that, so it is saved on the Seestar. So we're going to click in the center here and click on the Seestar. And then this album shows things in chronological order. But it does do the solar system album first and then the stargazing album. But then inside those albums, they are in chronological order. So the first one we see in the stargazing album is NGC 7023. And then next to that is the subs folder. That is that Iris Nebula that we did the later part of last night's plan. And then next to that is the M51. And you see that it has 3 objects in that folder. One of them is the one that just saved last night when we were sleeping. And then the second object is the one we saved right before we went to bed, and it ended right before midnight. And so there's a third one in there. And if we click on that folder, we can see all those. And you can see that we have one for today, we have one for yesterday, and then we have one from May 17th. And so those are those 3 objects that are there. And then the next folder is this M51 subs, and that has all of those exposures in it. So keep in mind that we did do different exposure rates. We did 10-second exposure rates and 20-second exposure rates. And it doesn't differentiate between those in this folder. It just saves every one of those subs. And so the ones from yesterday look just about the same as they do from the ones that we did during the night. So it doesn't separate those by the exposure rates. And you can export all of these files and stack them together. You don't have to keep the exposure rates the same in order to stack them. And so that's something that maybe everybody doesn't know, is that you can combine those exposure rates when stacking. All right, so we have them saved. And so now what we want to do is we want to go into our album here. All right, this one, this picture is the one that was taken between midnight and 2 a.m. And it saved 72 minutes of the exposure time out of the 120 that were available for it. I guess it's technically 118 because remember we had that 2-minute delay in starting the imaging. So between 72 and 74 minutes of saved exposure on that 20-second rate. That is it. Let's see. The picture here is the one from the 10-second exposure rate, and it saved 86 minutes. So even that 2 minutes didn't make the 20-second exposure rate as efficient. So the 10-second exposure rate saved 86 minutes of the 120 possible, and the 20-second exposure rate saved 72 to 74 minutes of that 120 possibility. So last night, the most efficient was the 10-second exposure rate. It just saved more for the same duration of time. So we want to compare these two. You can see as I scroll past them right here, I didn't do any enhancing at all in the app. No denoising, no darkening, no lightening, no cropping, nothing. And you can see that there's a lighting difference between the two. And that's probably because as my neighbors were going to bed, some of the lights were going out and it got just a little bit darker for the later one. That's my guess as to why that happened. But I'm kind of surprised because in past experiments, the 20-second exposure rate has always been the most efficient, but in this case, it is not. It's the 10-second exposure rates that is the most efficient. What I'm going to do on the next screen is I'm going to put up these two pictures side by side. I'm going to crop them down to just the object and enlarge them so we can look a little bit more closely at the detail. I don't know if we'll see a big difference between the detail between 86 minutes and 72 minutes, but we're going to try and do that. And then when we're done comparing those, I will put up a picture of that Iris Nebula that we did the later part of last night's plan. So that is my plan going forward. The image on the left is the 10-second exposure rate, and the image on the right is the 20-second exposure rate. And I can see quite a bit of difference. The one on the right has a darker background. The one on the left, the galaxy came out a lot more white. So the capture of light was different between the two. And, I like them both. They're both beautiful and they would both work really well in post processing. And so that's the results of our experiment last night of the 10-second exposure rate versus the 20. And I have to say the 10-second exposure rate probably beat out last night. And that's different than other experiments we've done in the past. So it's interesting to redo experiments and keep challenging and learning new things, trying to figure out what the differences are so that we can make the most of the time that we are spending out imaging. Next up, I will show you the Iris Nebula. Here is the Iris Nebula right off of the Seestar. It saved 170. Let me look here real quick. I'd cropped it on this image, so I can't see it. 156 minutes it saved last night. So over 2 hours of exposure. The one on the left here is straight off of the Seestar with no enhancing. And then I will put up the one where I denoised it and I just darkened it just a little bit so that the background would be a little bit darker. And that's all the enhancing I did on it and cropped it, of course. But so the one on the left is straight off the Seestar, over 2 hours of exposure. The one on the right is the same photo, just denoised in the Seestar app and darkened just a little bit so the background's a little dark. So that's the Iris Nebula, and I think it turned out beautiful. I'm really pleased with that one. That one too would be a really good one to do more enhancing and post-processing, but even right off of the Seestar, if post-processing isn't your thing, you can still get beautiful images straight off of the Seestar, and that's what we did last night. Again, thanks for joining in on the experiment. I hope you enjoyed this one, learned a few things, inspired some creativity in everybody. And as always, we're wishing everybody clear skies. Thanks for watching.